All right, we are doing lesson 97 today. Title is Recursive Rules for Sequences. So this is going to take us back to our lesson that we've done previously on formulas for sequences. I actually think that this is a little bit easier, and there's just really one trick that we need to make sure that we know. If we know that, we should be good. So we'll start with a little review, and then we'll get into the new bit with the recursive part of today's lesson. So here we go. So if I'm given the sequence 3, 6, 9, 12, then I know that I can fit that sequence into a table where I have a position and a value. And again, remember n is our variable, our symbol for position. A is our symbol or term for value. Okay, so here we go. We have the first, second, third, fourth, fifth, and sixth terms of the sequence. So we could plug those in, their values. So we know that the value for the first term, what's the first term in our sequence? That would be 3. All right, the value of the second term is 6. Third term is 9. Fourth term is 12. Right, we can probably, fifth term not given, but we can figure out that this is going up by 3 each time. And so that would make our sixth term 18, right? So another way that we could outline that is by saying that the A sub 1, right, the value of the first term is equal to 3. And we could continue. This is how we would designate what the value of each term is. The value of the second term, A sub 3, the value of the third term, A sub 4, the value of the fourth term, A sub 5, the value of the fifth term, right, so on and so forth, okay? So we can also come up with a formula for this, right? And we could say that the formula, as we've done so far, right, what we've learned so far, we could say that the formula, the value of any given term, A sub n, is equal to, and we have to remember, right, what is happening to n? How do I get the value with regards to n? So what do I do to n to get to 3? What do I do to 2 to get to 6? What do I do to 3 to get to 9? And so we would say we're multiplying by 3. We're multiplying n by 3 each time, right? And so we can now use this to find a term that's much farther down the line, the value of the 20th term, A sub 20, rather than going and counting to 20 here. We could say A sub 20 is simply 3 times 20, which is 60, okay? So today, we're gonna find out how to find a term given a recursive formula, all right? And so all that means is we are going to use the value of the previous term, all right? So what do I do to the previous term to get the next term? And so to find the value of the next term, right, I take the previous term and I add 3 to it, okay? So here's how that looks, all right? A recursive formula. Here's the recursive formula for this sequence. It's 2 parts. The first part is they're always going to give you the value of the first term, all right? So that is a given every time. They tell you the value of the first term, and then they say, all right, very similar looking so far, right, as to what we've had. The value of any term is equal to, and again, I'm going to use something that tells me that I need to use the previous term in the sequence, and what do I do to it? So the value of any term here is I take the value of the previous term, and I add 3, okay? So this is the new part in today's lesson. And all this is the value of the previous term. So we would read this as the value of the previous term. So if I want to find the 100th term's value, then I need to know what the 99th term's value is and add 3 to it. That's it. Okay. So let's apply this to this, right? And so if I want to find the second term, I'll go red. All right. So let's say, what is the second term? We know that it's 6, right? But the value of the second term is going to be the value of the previous term. So we say a sub 2 minus 1. So again, we're just substituting 2 in anywhere there's an n. So just like we were doing before, right? When we wanted to find the second term, a sub 2, we plug in a 2 here and get 6. When I want to find the 20th term, a sub 20, I plug a 20 in for n and get 60. All right, so all I've done here is plug a 2 in where there was an n previously. So this tells me the value of the second term is equal to the value of, well, a sub 2 minus 1 is going to be a sub 1, right? Which would be the first term, the term before 2, plus 3. Okay? And so again, we can take that, right, and say that a sub 2 is equal to a sub 1 plus 3, right? All I did here in this step was simplify that portion, all right? And we know we're given a sub 1, right? So a sub 1 is 3. So a sub 2 equals, a sub 1 is 3, 3 plus 3. So a sub 2 equals 6. Okay? All right, so that's really it, okay? So that's an example of a recursive formula right here. So we'll do a couple more, all right? So let's go to a new slide. All right, so here are some notes real quick. A recursive formula. All right, has two things. One, it gives you a rule for the first term, right? Okay, and that's going to be shown as a sub 1 equals, right? Okay, the second thing that is involved in a recursive formula is a rule for all other terms involving the value of the previous term. And so that's going to look like a sub n equals a sub n minus 1 dot dot dot. Okay? All right, so these are the two characteristics of a recursive formula. All right, so let's do another example. Go green. All right, here's our sequence. 3, 6, 12, 24, 48, 96, dot, dot, dot. So here's our sequence. All right, and as you can see, hopefully, that we are going up by 2 each time, right? So to get from one term to the next, I have to multiply by 2. Okay, and so we could say, right, for a recursive formula, number 1, I need to know the value of the first term. A sub 1 equals 3. All right. Number 2, I'm going to come up with something that involves what am I doing to the previous term to get the next term. So I go a sub n equals what is happening to the previous term to get to the next term? So all I'm doing is multiplying the previous term by 2. So 2 times a sub n minus 1. All right, so there is your recursive formula. You're gonna put it in a brace like that. And now we can check, okay? So let's check to make sure that that's true. So let's say we know the third term is 12. So if we want to find the third term given this formula, all I'm doing is plugging a 3 in everywhere there's an n. Okay, so I plug a 3 in everywhere there's an n. Next line, the value of the third term is going to equal 2 times a sub 2. Well, a sub 2 is 6. So the value of the third term is going to be 2 times 6. And so the value of the third term is 12. Is that true? Yeah, it is. So we know that our recursive formula is correct. Okay? Let's do another. All right. Let's go with this. All right. So we're just going to be given a formula this time. So the formula is a sub n equals 2 plus 2n. Okay, so let's find out what this sequence looks like. So the value of the first term is going to be 2 plus 2 times 1. So that's 2 plus 2, so that's 4. The value of the second term is going to be 2 plus 2 times 2, which is 2 plus 4, which is 8. I'm sorry, 6. All right, a sub 3 is going to be 2 plus 2 times 3. So again, all I'm doing is plugging a 3 in everywhere there's an n. So that equals 2 plus 6, which is 8. Okay. So our sequence, if we can see here, we're starting at 4. Second term is 6, 8. It's going up by 2 each time. Okay. So here's our sequence. So we want to write a recursive formula that fits this sequence. So again, the first thing that I always need to do with the recursive formula is start with a sub 1. What is the value of the first term? Well, that's 4 here. All right, I found that out already. Then I'm going to come up with a rule for all the other terms that involves the previous term. So the value of any term is equal to the value of the previous term, a sub n minus 1. Remember, that's always what that stands for. And what am I doing to the previous term each time? Well, to get to 6, I have to add 2 to the previous term. To get to 8, I have to add 2 to the previous term. So I'm taking the previous term, and I'm adding 2. Okay, so there is our recursive formula. I can check this, right? Let's say we want to find the fourth term. So I know the first term is 4. The fourth term would be a sub 4 equals a sub 4 minus 1. Just plug in a 4 everywhere there's an n, plus 2. So this would be, simplify this, that's 4 minus 1 is the third term, right? And that's good. That's the term before the fourth term. I need that. So the value of the third term plus 2. Well, the value of the third term was 8. So is the value of the fourth term 8 plus 2 or 10? Yeah, it is, right? We've already found that out. So then this recursive formula works. All right. Here we go. Couple more. I'll give these to you. You see if you can pause it and find the recursive formula for each of these. All right. So first, number 1. I'm just going to give you the sequence. 5, 10, 15, 20, Write a recursive formula for that. Number 2. 1, 6, 36, 216. Write a recursive formula for that. And last one. Number 3. I'm going to give you the recursive formula. Give me the second and third terms. Sorry, I keep doing that. Okay, so pause it here, work on these, see if you can come up with an answer for all 3. I'm going to go ahead and go through it now. All right, so the recursive formula for the first one, I know has to include 2 things. The value of the first term, which is 5. And then what am I doing to the previous term to get the next term? Well, I'm adding 5, right? Each time I'm going up by 5, so I take the previous term, a sub n minus 1, and I add 5 to it. Okay? So there's your answer to number 1. Number 2, I know that it follows 2 things. First term is 1. I'm halfway done, right? And then the value of any term, I take the previous term and I do what to it? Well, I'm taking the previous term and I'm going up by 6 each time here. So I'm going to do 6 times a sub n minus 1. Okay? And then number 3, I'm given a recursive formula and I'm asked to find the value of the second and third term. Well, I'm just going to take this part and use it. So the second term is going to be a sub 2. Just plug a 2 in anywhere there's an n. 5 times a 2 minus 1. And so that would really be, I'm going to remove this down, equal to 5 times a sub 1. Well, a sub 1 we're told is 10. So it's going to be 5 times 10, which is 50. So a sub 2 equals 50. There's one answer. The third term, I'm just taking the previous term and I'm multiplying it by 3. I'm sorry. Taking the previous term and multiplying it by 5, right? So again, I could go through this, but once I know it, that's kind of what's nice. If I know the term before, I'm just going to do what I'm told to do. So in this case, multiply by 5, but I'm going to say this is going to be 5 times a 3 minus 1. Again, just plug a 3 in anywhere there's an n. So that'd be 5 times a sub 2. Well, a sub 2 we just found is 50. So that'd be 5 times 50. So 5 times 50 is going to be 250. So a sub 3 equals 250. All right, so that's it. That's the lesson. Again, I think it's a little bit easier than what we've already done. So all you really need to know, all you need to keep straight is this is the new part, right? This a sub n equals a sub n minus 1. Sorry. Let me back up. This is what you need to know. That a sub n minus 1 is read as the value of the previous term. And that's the biggest thing from today's lesson, okay? If you can remember this, right? Just like we did with regular formulas, knowing that a sub n means the value of any term, that n is the position of a term, right? Then you're gonna be good, okay? All right.